Yes, hello everyone. My name is Destiny DK, and I'm going to be taking you through Physics Practical WAEC 2021 and what you are meant to expect. For this class, I'm going to be focusing on mechanics, okay, and how the experiment is expected to go through. All right. I am super happy to have you here. Let everybody relax, and please, if you don't understand anything, you pause, rewind as many times as possible. All right, you pause, rewind as many times as possible. If you still don't get it, I'll be in the WhatsApp platform. You can come to the WhatsApp platform to ask questions. All right, now let's go. Like you were told, the mechanics practical, it's all about oscillation, simple harmonic motion. Okay, if you don't understand what is oscillation, it's a kind of to and fro movement, like your pendulum bob. For those of you who have done it before, the pendulum bob, the swinging of the pendulum bob. It's just that this time around, it is not going to be the pendulum bob being used. It's going to be a meter rule, okay, all right, with two rope tied towards each ends. All right, the experiment in physics practical, we try to follow the instructions being given to us. All right, so the point, the centimeter mark along the meter rule, where you will have to tie your thread, okay, your two threads, okay, do you understand? It will be indicated in the question. Okay, if they tell you place the first one at the 10 centimeter mark and place the second one at the 90 centimeter mark, you just follow suit. All right, 90 centimeter mark is because the uniform meter rule being provided is always graduated. All right, it's always graduated, and they don't have any kind of two types. Okay, it's graduated from 0 to 100. All right, so if they say place it on the 90 centimeter mark, you place it on the 90 centimeter mark. They say place it on the 50 centimeter mark, you place it on the 50 centimeter mark. I want to make you understand something now, that the point you place the meter rule is immaterial to the results. Okay, it doesn't affect the results in any way. They are also going to tell you to place some masses along use a tape, maybe a sellotape, to place some materials along, some masses along different points of the meter rule. Okay, that is just to provide a center of gravity for it. Masses do not affect the oscillation of a body, okay, unless there is a spiral spring that is involved. This is not a spiral spring, so masses do not affect it. Okay, point one there, as you can see, all right, from your screen. Okay, question one is what is mechanics. All right, the setup is in form of a meter rule tied horizontally, you see, to two pendulums via two threads. Okay, one tied to each end. All right, it might not be the end. They might tell you, like I said before, they will tell you the points along the meter rule to which you will tie the thread. Okay, do you understand? Of course, question two is all about optics. All right, the setup is a lens, okay, of focal length 15 centimeter. That is beyond the scope of this video. We are just going to focus on the mechanics for this video. All right, now this lecture is all about how you can manipulate your way to accurate results and a near perfect graph. Now the point is that in physics practical, all right, every physics practical is a demonstration of a theory which you must have been taught. So there's always an aim to every physics practical, and this physics practical contains matter which obeys the principles that you have read in your normal theories in physics. Okay, they contain these things. They contain the form. They involve a process which obeys a particular kind of formula or a particular principle in physics. Okay, for this mechanics, there's a particular formula that it obeys, and that is why when you use this formula to manipulate your results, your readings, you get readings which are much more accurate than anybody that actually does the practical. Okay, you understand? So you get a nice an accurate result. Okay, and you don't get to spend time, because time is of the essence in physics practical WAEC. Okay, sometimes when you finish plotting your graph, the first graph, they say pens up. So because of that, you don't have time. You just have to find a way to get readings. And this video is also very important for those of you who might be in centers. I've seen many centers where the apparatus are faulty, or sometimes they just give you money, they just give you any reading. Okay, and they don't give you the opportunity to do the practicals. This is a way out for you. All right, so we are going to analyze how you can get your readings very well. Okay, now in the next slide, you are going to see the experimental setup to have a better understanding of this practical. Okay, the experimental setup is shown in the next slide. Okay, you have to obtain this time t. Okay, small letter t for n. That is how you are supposed to do the experiment. First, I want to describe how the experiment, if you were doing the experiment now, because you might not be able to know how to manipulate results if you don't know how to perform the experiment itself. Okay, so I'm just going to tell you what you are supposed to do, and then we'll go into how you can manipulate your results. You have to obtain the time t for n complete oscillations. Now, this is how it is. After tying that meter rule with the thread to the retort stand, as the setup we suggest, you're going to see it in the setup. Okay, as the setup we suggest, you tie it and then you allow it to oscillate. Okay, you displace it a little bit, you allow it to oscillate. 1 to and fro motion, okay, is one oscillation. Okay, they'll tell you determine the time t, small letter t, for maybe 15 complete oscillations or maybe 20 complete oscillations. I guess in whichever the case, n, capital letter N, is the number of complete oscillations. Okay, so they tell you determine the time t for 20 complete oscillations. That means n is equal to 20. So you have to allow it, you have to displace it, and allow, when you display, you leave it, it goes and come back 1, goes and come back 2, goes and come back 3, until it gets to 20. That is when you have to stop your before it starts, you start your stopwatch. When it's at the end of that last oscillation, you stop it, and then you note the time. That time you get is small letter t for n complete oscillations. Okay, do you understand? Okay, then after which you have to you have to use the formula connecting t and n with with the period. Okay, do you get it? Use the formula connecting time t for n complete oscillations and period t, okay, of oscillations to obtain the value of t. Okay, so after you get the small letter t for n complete oscillation, then you use the formula capital letter T is equal to small letter t over capital letter N. Are you getting it? That is what will give you an insight. That was what will give you the period t. You are going to use this formula. Capital letter t is the period. Okay, capital letter t is equal to what? The small letter t you got from the experiment divided by by the total number of oscillation. That will give you the period. This is what you are supposed to This is what you are supposed to do. All right, you use the formula capital letter t is equal to small letter t over n to obtain the period capital letter t. Remember, small letter t is in seconds. The period is also in second. Do you get it? Now you have to make sure that the length of the string is adjusted until 0 error is ensured. Okay, you have to ensure that the length of the string has been adjusted so that there is 0 error. Are you getting it? Now this is where the problem comes in, because there is no way you can perfectly adjust the length of the string that there will be no error. There has to be error of some sort. There has to be some kind of error of some sort, and that is why, okay, doing the experiment yourself will introduce you, we make you open to many errors. So when you manipulate values, you tend to get what? A more accurate value, because in this one you are getting it through calculation, so it's not prone to error. Okay, you are getting through calculation, you get a more accurate value that is even less time consuming than others. All right, so that is now this is the experimental setup, okay, for the experiment. Okay, this is how it is. You can see the two retort stands holding the horizontal meter rule, okay, in position by the help of two threads tied towards each ends. You can observe that in the first one there is no mass to provide a center of gravity. However, in the second one there is a mass. That mass helps to helps to give the experimental setup a balance. Are you getting it? And that is what they are going to tell you people to do this time around. All right, so everything is as arranged. This is how it's going to be set up. L there is the length of the string, that is from the retort stand to the meter rule. That is your L. Are you getting it? In the second experiment, you see from one thread to the other is D. Okay, you look at the diagram and follow the instruction accordingly as it is supposed to be. Having understood the what you are expected to do, are you getting it? For each practical, are you getting it? You are to you are to use whatever to get whatever you want. But then that is not the essence of this video. This video is to show you how well you can manipulate at short time, just within seconds, okay, within minutes. Okay, you've gotten the value you are looking for. Okay, and then you just draw your table and then you plot your graph. There is no time in physics practical, and that is why I'm doing this. Okay, this experiment takes its root from this formula you are seeing on your screen. Capital letter T equal to 2 pi root L over G. 2 pi root L over G. Now that capital letter T is the period. Okay, it is called the period of the period of oscillation. Then L is the length of the string. Take note, L here in this formula is telling us is the length of the thread from the retort stand to the meter rule. Take note of that. Are you getting it? When you are manipulating, you need that very well. L is the length from the meter rule, from the retort stand to the meter rule. All right, and it is in this formula. When you want to apply it in this formula, you must obtain it in meters. Are you getting it? You must obtain it in meters. T is the period. Okay, that is the experiment you are going to be doing on the day of physics practical should and must obey this formula. If it doesn't obey this formula, then you are assumed to be wrong. Now the idea is this. Okay, it's not that people that their result is very, very, very accurate will be punished for being accurate or whatsoever. It is you that there is error. They will not start sympathizing with, since you had error, that means you did the experiment. No, they judge your answer by its closeness to this formula. Okay, if it is so irregular with respect to this formula, then you get the wrong answer. By all means, any constant they are asking you to look for, because every experiment has a particular constant they are looking at for, and that constant has a value. Okay, on Earth, it has a value that has been present over time, that some scientists have found it out. And once you do the experiment and you get that constant, it must agree with what is on ground. For example, if this experiment is to get G, the value of G, which is often the case most times, if this experiment is to get the value of G, then whatever you do after you plot your graph and do everything, you get the slope of the graph and everything must give you at least either the value 9.8 meters per second square or close to it. If the value of G is 9.8 and you are guessing maybe 13 or 14, then it only says that what your experiment does not obey this formula, and that is what they will use to grade you. So, and that is why it is very important to use to use the formula to get value, to estimate your values. After estimating your values, you can use it for you can plot your graph, and then you see how perfect your graph is. Okay, so T is the period of oscillation, pi is of course 22/7, L is the length of the thread, and G is the acceleration due to gravity. Okay, now the idea is this: they will just be changing the L, the length of the string, from the Richter stand to the meter rule. Okay, they will just be changing the length of the string. That is the idea. They will be changing it, and then you are meant to as for each length you conduct the experiment. That is what you are expected to do anyway. For each length, okay, they tell you set L equals to 10 centimeter. You set it to n, you do the experiment, you calculate the time, small letter t for n complete oscillation, then use that small letter t, capital letter t is equal to small letter t over n, get your t. That's what you are supposed to do. Am I communicating? So, but in this case, you are going to just run the experiment. You are not going to do the experiment. Okay, use the L they gave you to set it as, put it in this formula, use it to get your capital letter t, your period. Am I communicating? Then use that same formula, capital letter t equal to small letter t over n, to get your small letter t. That is, make small letter t so your formula. Okay, for example, if you put L equal to 10 centimeter here, 10 centimeter, you have to convert 10 centimeter to meter. So after converting it to meter, you put the value in this formula. Okay, use pi equal to 22/7, get your capital letter t. On your rough book, take note, you must do this on your rough book. Get your capital letter t. After getting your capital letter t, okay, you use your capital letter t to get small letter t using that same formula by making small letter t the subject of formula. That is, small letter t will now be equal to what? Capital letter t times n. N will still be your number of oscillation. So after getting that capital letter t, you go to your booklet, okay, your main book, write that small letter t, because you are expected to get that small letter t first. Okay, according if you were running the experiment, you are expected to get that small letter t first. Then get the small letter t, okay, do it to 2 decimal places, because most of our digital stopwatch is in 2 decimal places. Okay, however, when you are using that small letter t to get your capital letter t in your main answer booklet, you must use the real value of small capital letter t you got from your manipulation. Okay, as time goes on, you can see the relationship required for using this experiment, right? Capital letter T equal to small letter t over n. Are you getting it? I've already explained this formula to you. Capital letter T equal to small letter t all over n. Are you getting it? And that is when you are doing the experiment normally. You want to use that small letter t to get your capital letter t. Okay, just divide it with n. That will give you your capital letter t. Are you getting it? However, if you are manipulating, you've gotten your capital letter t first using that formula. Then use this formula, make t small letter t is your subject of formula. You get your your capital letter, your small letter t. Do you get it? Do the following in your rough book. I have told you already. Everything you see here is what I've told you. You put the value of L, that is the length of the thread, in the formula provided. After which, that is the formula is what? Capital letter T is equal to 2 pi root L over G. You are going to put L in that formula. The L they told you to set for this. You are expected to do 5 experiments for that mechanics. Okay, for each of the experiments there are different value of L, which is the length of the thread. Okay, from the pendulum to the thread. Put the value of L in the formula provided. So you put the value of L in the maybe they say set L equal to 15 centimeter. So you change that 15 to what? To meter. Okay, that will be 0.15. So your T will now be T equal to 2 pi root 0.15 over 9.81. That will give you the capital letter T. That they say obtain the value of the period T by substituting the values of the constants pi and g. The value of the constant, pi and g. Pi is 22/7, g is what, 9.81. Okay, so that will give you capital letter T. Then they said use T equal to what, small letter t over n, to find the value of what, of small letter t. This place is not small, it's not capital letter, is what is small letter t. Do you understand? Use the value of the t equal to what, small letter t over n, to find the value of small letter t. That is, you are making the small letter t the sort of formula. That is, small letter t equal to what, capital letter T times n. Okay, now after getting this on your rough book, they say on your answer script, that is on your real answer script, impute the value of small letter t first, okay, in seconds. Okay, so you know, in your rough book you got capital letter T first, then you use that capital letter T to get what, small letter t. But in the experiment, remember that you are supposed to get small letter t first before capital letter T. So you put what, the small letter T. Are you getting it? Then we are going to have a practical demonstration so that you understand. Okay, you put small letter t first in 2 decimal place. Then what, you use the value of what, capital letter, you put the capital letter T second. Or you can use that, you can do as if you are using that small letter t now to get capital letter t, using that capital letter t equal to t over n. You solve it. But whatever you get, try to make sure that it is the value you got from the formula, that capital letter T. Using the value you got from the formula is extremely important, if not the most important aspect of this experiment. Now, on your answer script, impute the value of capital letter small letter t first in seconds in 2 decimal places. You see, use the formula capital letter t equals to small letter t to get the value of what, small letter t. Okay, to get the value of capital letter T, okay, the period, which will be the same as the one you got using the manipulating formula. It must be the same as the one you got from your manipulating formula, because that is the essence of manipulating. Okay, let's try this demonstration. They said let us assume that the first value of L is 10 centimeter. Let us assume that the first value of L is 10 centimeter and the number of oscillations is 20. This is just assuming. That means they said you should, whatever they tell you to do, the length from the retort stand to the meter room should be 10 centimeter. Okay, they said, and you are meant to what, to get the time t, that is small letter t, for 20 complete oscillation. Okay, now you want to manipulate. You are going to get capital letter T first, that is the period. Okay, you are going to get capital letter T first, which is the period. Now you are going to put, they say putting it in the manipulating formula, we obtain t equal to, if you put this 10 centimeter, that is 0.1, you have to divide by 100 to convert to meter. Okay, 0.1 in that L, in t equal to 2 pi root L over g. Okay, if you do that, you will get, using pi equal to 22/7, you will get 0.6346 seconds. Okay, we then use formula, are you getting it? T equal to what, capital letter T equal to small letter t all over n, to find small letter t. Okay, of course you have capital letter t equal to 0.6346. you put it as in place of capital letter t there, put n in place as in place of 20. Okay, you put what, 20 in place of n there. Okay, you have, okay, or you can just make small letter t is a formula, like by saying what, small letter t is equal to t times n. That is what you have there. Okay, so if you say small letter t equal to t times n, okay, that means 0.6346 times 20. Are you getting it? All right, if you do that, that will give you into that, remember that small letter t is supposed to be in 2 decimal place, that will give you 12.69 seconds. Are you getting it? Then on your answer script, after getting this in your rough book, now on your answer script, you now write, okay, you now write t equal to 12.69 seconds. Are you getting it? Do you understand? Small letter t equal to small letter, since it's the first experiment, okay, because you have to run it 5 times. Each of the experiments is different value of L. Are you getting it? Okay, so small letter t, now with 12.69 seconds, you make it as T1. T1 will now be 12.69 seconds. Then now you now write also capital letter T equal to T over N, because you are trying to show them that you got this T first. This T is when you did the experiment by yourself. So that means you are supposed to get that period, okay? Do you understand? So you do as if you are getting it. You do what? Capital letter T equal to what? Small letter T over N. Okay? Then that will be 12.69 over 20. Okay? That is your 12.69 is this over 20. Now if you do this in your calculator, it will give you a slight difference from 0.6946 seconds, but you want to use the one you calculated for using that formula. So that's why you, irrespective of what your calculator gave you as 12.69 divided by 20, okay, irrespective of the value your calculator gave you, you write whatever you calculated initially using that formula for a period. Are you getting it? That is what? 0.6346 seconds. I hope I am clear. If you don't get it, you pause, you rewind, and you listen again so that you get a full detail of what it is. Now we want to assume another value. Let us also assume that the second value of L, maybe they said repeat the experiment for 4 other value of L equal to 20 centimeter, 30 centimeter, 40 centimeter, and 50 centimeter respectively. Do not tell you in each case determine the value of what? Small letter T, or you say T, okay, and capital letter T. Are you getting it? Whatever the case, okay, this is second experiment. So your L2 will be what? 20 centimeter. Remember, for each experiment, you are going to be recording the value of L2. Okay, so the first one, L equal to 10 centimeter. That's what you are going to write in your answer script. That is L1 equal to 10. This one now will now be L2 equal to what? 20 centimeter. So this time around, now if you want to put in that experiment, it will now be what? 0.2. That is divide that 20 by 100 to convert to meter. That will give you 0.2. So you put that 0.2 in the experiment. That will be T equal to 2 times 22 over 7 times square root of 0.2 over 9.81. Are you getting it? When you do that, you are surely going to obtain capital letter T equal to 0.8975 seconds. Are you getting it? So we then use the formula capital letter T equal to small letter T over N to find what? To find T. Is it not? To find small letter T. That is small letter T will now be T times what? N. So that will give us what? Your capital letter T is what? Your period is 0.8975. Now is 0.8975 times 20. Okay? That will give you what? 17.95 seconds. The same thing, the same way you are going to do it. Okay, so but on your answer script, you will now write small letter T2 now. Will now be what? 17.95 seconds. Okay, you are now going to write capital letter T equals small letter T. That is capital letter T2 will now be small letter T2 all over N. That will be 17.95 okay seconds all over 20. Irrespective of what this gave you, you must use the one you got from what? From your formula. Are you getting it? That will now be 0.8975 seconds. Are you getting it? Now we are presented with an example here. All right, they said you are provided with 2 Richter stands, 2 meter roots, some masses, a piece of thread, a stopwatch, and other necessary materials. Set up the apparatus as illustrated in diagram above. That is in that other slide. You remember now the diagram that we have there. Measure and record. That is for the second one. Okay, that the second one that contains H. The second diagram. Are you getting it? That contain H. Okay, and the mass on top. Right. That is one we are using for this one, for this experiment. They say measure and record the distance H equals 130 centimeter. Are you getting it? Measure and record the distance H equals to 130 centimeter from the meter rule to the point of suspension of the meter rule. Are you getting it? From the meter rule to the point of suspension. The point of suspension is what? Is on the what? On the Richter stand. Okay, that is where the meter rule was suspended from. Are you getting it? So that means from that Richter stand to the meter rule where you tie the thread should be 130 centimeter. All right, it should be 130 centimeter. Okay, do you understand? Then they said displace that means that h equal to 130 centimeter, that one is your already L. Remember, no matter the arrangement of the apparatus, let the L you are putting in the formula to manipulate to get your capital letter T, let it be the distance from the meter rule to the retort stand. Very, very, very important. Okay, because sometimes they used to give something like to confuse you. Okay, all right, they might label from the retort stand now to the ground. They label it maybe as 200 now. Are you getting this? And then they now label from the retort, from the meter rule now to the ground, not to the retort stand, to the ground. From the meter rule to the ground. Remember I said from the retort stand where the rope is being tied, are you getting it? The thread is being tied to the ground is 200 centimeter. And they now tell you that they will not label it that from the meter rule to the ground is what? Is 130 centimeter. That means the length of the thread would be what? 200 minus 130, right? So you should know that no matter the arrangement, no matter the measurements, let the L that you are putting on that formula, in that formula, be from the meter rule to the retort stand. Are you getting it? In case they want to confuse you with that other thing. Do you get it? But in this case, they said from the meter rule to the point of association of the meter rule, you know now, to be 130. That means our L will be 130 centimeter, which will be 1.3 meter. Okay, let's continue. They said displace the meter rule, the pendulum, through a small angle and release. Of course, allow the pendulum to oscillate freely. Determine the time T. You see, T for 20 complete oscillation. Now they said also determine the period T of the oscillations. Okay, the period T of the oscillation. You know how to get the period T of the oscillation now. Capital letter T is equal to small letter T over N. Are you getting it? Then you say evaluate T square and L equals H over H minus 30. Okay, just obey the instruction. Okay, the value of capital letter T you get, just square it. Are you getting it? Then find L equals H minus 30. Now this L is the L for this experiment, but the L you are putting in that your formula should be what? From the, I've told you, from the meter rule to the what? From the meter rule to the retort stand. Okay, all right. You were also told to repeat the procedure for 4 other values of H equals to what? 110 centimeter, 90 centimeter, 70 centimeter, and 50 centimeter respectively. Then tabulate your readings. Okay, so you are going to do all of them. In each of them, you are going to get your small letter T, your capital letter T for each of them. Then you say tabulate your readings. Plot a graph with T square on the vertical axis and L on the horizontal axis. Okay, determine the slope S of the graph and intercept C on the vertical axis. All right. Now you look at the solution there. In your rough book, everything just goes along with what I taught you. In your rough book, you know that H1 will be equal to what? 130 centimeter. L will be equal to 130 centimeter because H there is talking about from the meter rule to the retort stand. Okay, so it's like that. H will be equal to what? H1 will be equal to 130 centimeter. L equal to 130 centimeter. Okay, so since L equal to 130 centimeter, you divide it by 100 to what? To get your what? Your value in meter. Then use that in what? You use your formula T equal to 2 pi root L over G to get your what? Your capital letter T. Are you getting it? So your T1 will now be 2 times 22 over 7 times root of 1.3 over 9.81. If you do your calculations very well, you should be getting 2.2882 seconds. Okay, all right, you get 2.2. Then you now use what? Your T1 equal to T times N, capital letter N, to get your what? Your small letter T. That will give you 45.76 seconds. All right. That is your, now in your answer booklet, you are now going to what? Put that T1 first, your small letter T1 first, 45.76 seconds. Then you now use your t, capital letter T equal to what? Small letter t over n to get your what? Capital letter T. But if you use this approximated value 45.76 over 20, you will get a value slightly different from the capital letter T you got from your rough work. Okay. However, is that one that you got from your rough work that is very important. You put it irrespective of what the value it gives you. Okay. Then you get your L1. Your of course your L1 will be for your experiment. They told you now the formula that is H minus 30, which is in this case 130 minus 30 equal to what? 100 centimeter. Am I communicating? You go to the next one. Now L changes, right? Your H changes from what? From 130 to 110. Every other thing remains the same. Your L becomes 110 centimeter. Are you getting it? When your L is 110 centimeter, you follow the formula again. You solve using the formula. Okay, if you use the formula, you did this very correctly. Okay, you get what? 2.1059 seconds. Okay, then your T2, okay, your T2 becomes T times N, which is what? Your small letter T2 becomes what? T times N, which is 2.1059 times 20. Okay, in two decimal places, you approximate it, you get 42.12 seconds. Are you getting it? I hope I am not too fast. If it seems I'm too fast, you know what to do. You pause it, you rewind it, and then you play again as many times as possible until you get it. Okay? In your answer booklet, you are now going to put your small letter T2 first for 2.12 seconds. Then capital letter T2, okay, for 2.12 divided by 20. You put the value you got from your rough work, not the value you get from that division. Okay? That will give you 2.1059 seconds. Okay, then you get your L2 as what? 10 minus 30 again. I'll give you 80. You see that in every other thing, everything remains the same. What is changing is your H. Your new H is what? 90 centimeter. Okay, then you put 90 centimeter in the formula, but you convert it to meter first. That will give you 0.90 meter. You put it in that formula, you get your what? T equal to 1.9039 seconds. Okay, I hope you are with your calculator. Each time you get to this calculation, you pause and then you calculate. Okay, practice the same makes perfect. You calculate yourself. So T3, small letter T3 will now be T times N. You do that, you get 38.08 seconds. Okay, in your answer booklet now, you now put your small letter T3 first. 38.08 seconds. Okay, your T, capital letter T3 will now be, you know how to do that, right? You still put the value you got from your rough book, which was 1.9039 seconds. Very important. Okay, also you get your L3 equal to what? 90 minus 30, which is 60 centimeter. Okay, all right, you go to the next one. You know, the next one, H is equal to 70, so your L becomes what? 70 centimeter. Are you getting it? So which is what? 0.7 centimeter. Okay, you put that in that formula, you are supposed to get 6791 seconds. Okay, then from there you get your what? Your T4. Okay, as 33.58 seconds. Okay, now after that, what do you do next? You put it in your answer script, but putting small letter T first and followed by capital letter T, the same way we did, and your L. All right. This is the last one. Okay, in your rough book, your H5 is 50 centimeter, so your L will be 0.5. Put it in the formula, you get 1.4191 seconds in T as T5. So your small letter T5 will now be what? T times N. Everything will now give you 28.38 seconds. Now in your answer booklet, you put it as well as I told you, and then you get your values. Now this is your table of values. Okay, you have to obtain T square, right? Remember, you have to obtain T square. So this is your essence for the number of experiments you are doing. 1 2 3 4 5. Okay, then this is your H, which is 131 or whatever. Then this is your L. They ask you to guess. Remember, L is equal to H minus what? 30. you get them here. Then these are your t's you got, okay? All right, so you put them there. Then these are your periods, okay, in seconds, you put them there. Then remember they say you should evaluate t square, you put them here. Are you getting it? Okay. First I will have to teach you how to plot graph. So in my next physics class, I'm going to teach you how to plot graph, okay, so that you know how to plot graph very well, that according to WAEC rules and regulation, you'll be able to get the highest possible marks when you see your graph. Remember that your graph is what is the most important thing in your experiments. Your graph will expose whether your results have been so accurate or so inaccurate. That is what your graph will show you. Most times they just mark your scripts from the beginning to this point, okay, but your graph tells you, is an interpretation of your results. How accurate are they? Do you get it? All right. You get a word of advice from me, okay? Your best is peculiar to you alone, okay? All right, you can see the advice here from me, okay? Your best is peculiar to you alone, okay? From the tables of Scholars Horizon, okay? That's my initiative to get education. All right, to get education to reach as many people as possible, okay? All right, okay, your perceived best might not be your truest best, okay? Your best is what produces results, okay? All right, so many people that will be doing the experiments might be doing their best, but the results they get might be very, very inaccurate. All right, so thank you very much. On a final note, I say thank you to every one of you. I wish you all the best.